Good morning. It's a great pleasure to be here. I can't tell you how happy I am to be here to speak in front of programmers. I want to talk about something we care about a lot. We spend hours on writing code and maintaining code. Anything we can do to improve the quality of code is something we're going in the right direction. There are four kinds of people in this world. There are people who want to know what you're doing. The second group of people are, when will you get done? Usually the managers, right? The third kind of people, how do you do this? I'm the fourth kind of person, why are you doing it? Because if you cannot convince me why to do something, I wouldn't waste my time doing it. So I'm going to start with the question, why should we care about code quality? I'm going to say the very first reason to care about code quality is we cannot be agile if our code sucks. As simple as that. Well, we live in a world of agile development. Agile development is about feedback-driven development, to be able to adapt even late in the game. You're sitting in a meeting, and they're talking about making a change to this XYZ module, and you realize the last time you touched the XYZ module, you couldn't go home for the weekend. You're going to convince them this is not what you really want to do. So if you want sustainable agility, code quality is very important. But then I realized there is another reason why we should really care about code quality. Because code is how we tell our colleagues how we feel about them. Do we love them or do we hate them all? This is how we communicate using the code we write. So the code you write shows them how you really love them because somebody comes to maintain the code after we write it. So the quality of code is extremely important from the point of view of humanity because other people are going to maintain the code we are creating. So I'm going to talk about 12 ways to improve the code quality today. And I want to talk about what are some of the ways in which we can be effective. Some of this you may know already, but it may give you a new energy to go back and try this on your own projects. And maybe I'll give you a few ideas probably you didn't think about before. So let's talk about this. But one of the things to keep in mind is lowering quality actually lengthens the development time. This is the first law of programming. So we really want to focus on a better quality code to really improve speed of development. So we'll talk about 12 ways. But the question I want to ask first is, what is quality? And this is one of the challenges because in our field, it's really hard to define things where everybody can agree. The other day I was talking to a developer and he had a really weird way of developing quality of software. He said this code is great because I wrote it. I don't think that's a good definition. So we need to really have a better way to define it. Here's my definition. I'm going to say the quality of code is inversely proportional to the amount of effort it takes to understand it. If a code is a better quality, we take less time to understand it. If a code is a poor quality, we brood over it and spend a lot of time on it. So we definitely want to be able to build better quality software because it actually is an economic impact. It reduces the time it takes us for us to really maintain the code. That's another reason we want to focus on code quality. So we'll talk about 12 ways. I'll start with the first one, and that is schedule time to pay technical debt. Well, Ward Cunningham coined this term technical debt. You don't even have to do anything to really accrue technical debt. That's one of the problems. The software you released 4 months ago, you didn't have much reason to change it yet, but yet the framework that we're using has gone through 5 revisions already. That's a debt you have to really keep up with, otherwise it becomes really hard. Oh, that schema we've been developing over time, it really is not in shape. We need to spend time to refactor it. We haven't had real time to do it. A lot of these things can lead to technical debt. But writing poor quality code intentionally is not a technical debt. It's an act of sabotage. So we have to be very careful about it. But one of the things I do when I go to companies is when they tell me they have technical debt, the first question I ask them is, show it to me. In the room where we work, on the wall, I want the technical debt to be written down from the order of the most important and critical to the least important. And the reason I want this to be written down is, when do we normally talk about the issues with technical debt? We do this during retrospection. We do this during meetings. But when you have put it on the wall, when you are writing code on that Wednesday afternoon, you look up and see the wall and ask the question, the code I'm writing now, is it going to be good quality or is it going to end up on the wall next week? So it's an important thing to really put it up on the wall as a priority. And once we do, then we can start scheduling time. Maybe she will spend 15% of her time in the next sprint on the first technical debt. Maybe she will spend the 15% of her time in the next debt, and he will spend the 10% of his time on the third debt, and we will have people really dedicate time to pay this technical debt along the way. So schedule time to pay these technical debt as well. That becomes extremely important. So on a project, we spend a lot of time on development. We spend time on meetings and other activities, but we also have to really purposefully and intentionally schedule time to pay technical debt as well, so we can start really reducing the technical debt along the way. That's one of the first things, is to be very purposeful and dedicated to it. So identify the debt, list them down, and start scheduling time to pay the technical debt. The second thing I want to talk about here is about really focusing on how to really improve quality by improving cohesion. So what is cohesion? Cohesion is where a piece of code is narrow, focused, and does one thing and one thing really well. Well, once again, why? Because it reduces the frequency of change of a piece of code, and when the frequency of change is lower, it reduces the cost of changing the code as well. So we want to increase cohesion in the software. So when a piece of code is doing one thing and one thing really well, it is called cohesion. How do you measure cohesion? Well, we could look for the cyclomatic complexity of code, for example. If the cyclomatic complexity is high, that is a reflection of low cohesion. It reminds me of an experience I had. I have a client I'm working with. They have been developing this software for 30 years. Can you imagine walking into a company and sitting with developers, and there are developers who are there and tell you, I wrote the first line of code on this software. It is nerve-wracking to work with people who wrote first line of code on the software 30 years ago, and they are still working there, waiting to find out if they will retire first or die first. This is amazing to have these kind of developers still working on the code they created. And they have a version control with 30 years of source code in that version control. And as I was talking to them, one of the developers said, come over, I'll show you something. And he goes to the version control, drags the timeline to 15 years ago, and shows me this function. That's the day this function was born. So beautiful. I could see its entire naked body in front of me. Little fingers, only 2 parameters. And I was like, wow, so cute. And as I was praising it, he showed me the cyclomatic complexity of this function, a value of 5, when a complexity value of 10 is considered to be really high. And as I was saying, amazing how beautiful this function is the day it was written, he said, don't get carried away. And he grabs the timeline and moves to the current date. And in front of me, I see this function turn into a monster. I cannot see its bottom anymore. And don't even ask me how many parameters this method has. And I'm like, wow. And then he shows me the cyclomatic complexity of that same function, which was 5 on the day it was created, a value of 864. And he said, that's what we do to code in this company. I'm like, where's the nearest door? I want to run out. I need to get some fresh air. Well, this is what happens to code if we don't refactor it continuously. It turns into a monster. So high cohesion is extremely important. The next thing is to favor loose coupling. We all talk about it. What is the ugliest keyword in Java? I'm going to say the ugliest keyword in Java is new, because you are asking for that very specific class to be instantiated. And we have an entire slew of design patterns and inversion of control, dependency injection, frameworks created so we poor developers don't have to use new in our code. So this is one of the things that tightly couples code. What do? We rely on interfaces to do loose coupling. But I'm going to go further. Instead of loosely coupling, I want to get rid of coupling where possible. And the reason I want to eliminate coupling is what you don't use doesn't bother you. As an example, the code in the middle depends on the code on the right. And because the code on the right is non-deterministic, it takes a lot of effort to really unit test and maintain the code in the middle, a lot of mocking. But I realized that the code in the middle requires 2 pieces of data, one that comes from the left, the other comes from the right. We can refactor it and say, I'm going to pass the 2 pieces of data. I've started realizing this more and more. We are bringing in dependencies, what I would like to call as accidental dependencies, and then we end up really suffering with it. By eliminating dependency actively, where possible, and there's more places where it's possible than we actually try, we can actually reduce the complexity of code quite a bit in our effort, and that is something I would emphasize we should do more often as much as we can. The next thing I want to talk about is program with intention. Now, how many of us write code where everything works? Yeah, nobody raised the hand. That's right, right? We all try to make the code work, and we're sitting there and struggling oftentimes, and we try crazy things. I was working for a client recently when I was trying to refactor a piece of code. I'm new on the project. I don't know what exactly is happening, but the good news is all the tests were passing. As I was refactoring the code, in a loop I sent an index variable, and the test immediately failed. I looked at my client and I said, hey, the code is failing. He said, try I+1. I tried I+1. The code immediately failed the test. I didn't even say anything. I kind of looked at him and shrugged. He immediately said, try I-1. I'm like, are you serious now? He said, maybe we should know what the code is doing. Good idea. This is called act of desperation, isn't it? We try all kinds of things to see if the code will work. And I think everyone in this room will agree to this sentiment from this programmer. The programmer said, when I wrote this code, only God and I understood what I was doing. Now God only knows. This is so true, isn't it? We all face this. Sometimes we look at this code and say, what is this code doing? The other day I saw a programmer really complaining about cursing the code. And then he realized it was him who wrote the code. He didn't even remember this anymore. So this happens a lot. It becomes really hard to maintain code when this happens. So the question really is, what can we do about it? This is one of the reasons I'm a huge fan of Ken Beck's rules of simple design. Ken Beck says, when we write code, we should follow 4 simple rules. The first rule he says is that the code passes all the tests. That's the first rule he says. The second rule he says is the code reveals its intention. The third thing he says is that the code will not have any duplication. And the fourth thing he says is that the code will have the fewest elements. He puts these in the order of priority, high to low. He says the code passes all the tests. There's an implicit assumption he makes in there, you realize, that there are tests to pass. And then, of course, once the code passes all the tests, it reveals intention, but only then do we remove duplication, and then the minimalistic code. This is one of the reasons I'm a huge fan of writing tests. Before writing code, it makes me think about the intention and then come back and write the code. The next thing I will emphasize here is to avoid primitive obsession. We all do this all the time. We believe we have to write this code. Reminds me of an experience of a while ago. I was code reviewing, and I saw this 30 lines of code in front of me. I read the code, the tests were passing, but something was bothering me. So I read it again and read it again and read it again. And I said, why am I not liking this code? And that's when I realized this 30 lines of code was, all it was doing was string manipulation. And I said to myself, why did this programmer spend so much time writing the code to manipulate the string? I'm sure this has been done 1,000 times already. And I did a little search. And to my surprise, I found the code to do it right there in the JDK, except for one difference. The JDK implementation did not have the 2 bugs this code actually has. And what I did is I quietly commented out the 30 lines of code, wrote the one call to the JDK, made sure the test was passing, and I checked in, quietly said nothing. An hour went by, the programmer came along, looked at the code and said, gosh, Venkat completely commented out everything I wrote. Sat there and scratched his head for a few minutes and said, deleted the commented code, quietly checked in, walked away. That's a really good way to help programmers realize they're working way too hard than they need to. Nowadays, I tell my programmers to ask a very important question. When you sit down to write a piece of code, ask the question, are you the chosen one? If you are the chosen one, you should write the code. If it's a general purpose code, with all respect, somebody was chosen a long time ago. And they did a better job than what you and I can do. But if it's a domain-specific code, the chances are you are the chosen one, and you should be writing this code. So we should really avoid writing code that shouldn't be written. Reuse is better than rewriting all that code that can be avoided. I'm going to say imperative-style code is inherently complex. It is like me giving you a 5 kilos of weight and putting on your wrist and saying, code all day with the 5 kilos weight. How would you feel about it? Well, the way you will feel about it is the way we've been feeling about for a few decades now, because that weight I'm talking about is imperative style of coding. Let's explore this for a minute. Let's take a fairly simple problem and work through it. Simple problems require simple solution, isn't it? So here we go. We have a little function is prime that tells it whether a number is prime. I have a main, and what does this say? N is 101, K is 51, some random values. What does compute do? Find the total of the square root of the first K prime numbers starting with N. That's not rocket science. Simple problems require simple solutions, isn't it? So what do? Double result is equal to 0. That's the very first step, isn't it? I want to return the result we have at our hands. Then I say int over here, index is equal to n. Int count is equal to 0. What did I do just now? Totally useless code, isn't it? This is not adding any value. These are called garbage variables. In fact, when you're writing code, the chances are you didn't call it result. You called it t or temp. Because that's how you tell the variable, you don't deserve to live. I hate you, that's what you say, right? Because these are garbage variables. They're not part of the problem. They are artificially introduced as part of the solution we are creating. Then what do? Then you say while count is less than k, at this point, you come to a grinding halt and you ask the question, is it less than or equal to? Do you ever ask that question? Every single time. Because you write the code and you stop and say, is it less than or equal to? You're never sure about it. You're trying to do this. Do I stop at that or go one less? And this consumes all our energy, isn't it? You are eating at home your lunch or dinner, and your family says, how was work? Fine. Are you okay? Yeah, fine. You look a little pensive. I'm fine. Are you really? I'm really fine. Just not sure if it's less than or equal to. You know, when young programmers ask me, what is that symbol? I always tell them, that is the symbol for confusion. Because that's what programmers do. They put it and they stop. It's like, what do we do now? And we're never sure about it, isn't it? Then I'm going to say if E is prime, and then what do? Index. If it is a prime number, result plus equal to, and then I say math dot square root of the value index. Well, I'm going to ask you the question, is the code correct? Come on, we are full of programmers here. Is it correct? No, what am I missing? Oh, that's right, index plus plus will increment the index. Is it correct now? No, what am I missing? Oh, count plus plus, is it correct now? You're laughing. You're saying, no, that's got to be outside. Is it correct now? You're like, no, this has to be inside. How do you feel about that? Is it correct now? Did you notice you went from it's wrong to I'm still thinking? I'll tell you one thing I've realized in my life. Programmers are the smartest people on earth. Because when you show them code and ask them, is it correct? They will never tell you it is correct. They'll tell you it looks good. Because they know in 3 weeks from now, it's not going to be correct. So it looks good. Well, when you write code like this is called accidental complexity, isn't it? This is accidental complexity because you show a code to somebody and ask them, what is this code doing? I'll tell you, our vocabulary is beautiful because we say two things when we say things, what we mean and what we really mean. And here's what people will tell you. If you ask them, what does this code do? And they will tell you, I will figure it out. What in the world is figure it out? That means I have no clue, right? So this is what it means. So usually, figure it out means I have no clue. I have to really extract the logic from code. That is accidental complexity. Why bother? So I have this theory. It is the code like this that prematurely turns programmers into managers. They're like, I'm done. You guys do the coding. I'm not going to do this anymore, right? And this becomes really hard to sustain in the industry. But I'll tell you one thing. I've got some good news for you. The people in this room, we have a name. We are called the survivors. Because some of you are experienced. I won't say older. I'm getting older. Some of us are experienced. Some of us are very young. But I want you to think about this for just 1 minute, if you will. Can you just think about the day, the very first day you wrote your very first line of code? What happened? You wrote your code and you said, yes, I'm a programmer. And the person next to you looks at you and says, did you compile it? And you're like, oh. And then you compiled it. And what happened? The compiler spit on you. And you were in a panic. You're in a state of shock. And then you told yourselves, they warned me about this. They said programming takes effort. And what did you do? You wiped your face, and then you said, I'm going to code again. And then what happened when you fixed the compiler error? And you compiled it again, what did it do? Spit on you again. And the second day, and the third day. And then after 15 years of coding, you write the code, and you compiled it. What did the compiler do? Spit on you yet again. And this time you said, I'm here for the long run. We are the survivors. But it doesn't have to be this hard. Maybe we can make things a little easier on ourselves. Let's try it. Notice what I'll do now. Let's go back to this code real quick. And rather than doing all this extra work, let's get back to this code and say, return stream.iterate. So stream.iterate, starting with the value n that was been given to us, comma, given an element plus 1. Just stop at that one line and see what it does. What is that? That's called an infinite stream. What is an infinite stream? It starts with n plus 1, n plus 2, n plus 3, n plus 4, n plus 5. It keeps on going up to infinity. I know what you're thinking. Oh my God, if it's an infinite stream, where would you store it? On the cloud, of course. But the point really is, you take this one, and then you say filter. And then what do you do with the filter? Filter, you say sample is prime. Then you say map to double, math, and square root. Then you say dot limit. Limit what? K. Hey, is it K or less? It's K, damn it, keep moving. Don't have to worry about it. And you run the code, and it produces the same result as the other one did. Now look at the two pieces of code for a minute. Which one would you rather write? Would you write the top code, or would you write the bottom code? I'll tell you what we will write. We will write the top code if we are consultants getting paid by the number of lines of code we write. Bottom one, we want to go home after getting the work done, isn't it? So the point really is, it doesn't have to be really complex. So I have this, another theory, a good code should read like a story, not like a puzzle. When you write code, when a code reads like a story versus a puzzle, when you write a code, we write a code and nobody understands it. And they're all scratching their head. Sometimes they take a few hours to understand it. Sometimes a few days. Sometimes a few weeks to understand it. On that Wednesday afternoon, you're quietly working in your office. And at 2 o'clock, suddenly you hear the scream from the next door. And you're like, they got it finally, right? This is how we create puzzles. Keep in mind one thing. When your colleagues find your puzzle, they're not going to be quiet. They're going to return a favor to you. They're going to send the next puzzle to you. In the meantime, we have production code to release that's really hard to work. So I want the code to be really easy to understand. A good code should read like a story, not like a puzzle. This is one of the reasons why I'm a huge fan of functional style. In the imperative style of programming, you tell what to do and also how to do it. In the functional style of programming, it is declarative. In declarative style, you focus on what to do, not on how to do it. And as a result, this becomes a lot more easier to understand, easier to express, easier to work with. It removes the accidental complexity from the code. The next thing I'll say here is prefer clever code instead of prefer clear code instead of clever code. Question for you: anyone in this room has ever written a clever code before? Of course. Those who raised your hands, thank you. The others, I completely know what you feel. You never want to raise your hand in public for that question. I understand that. But everyone who has written code has written clever code, right? Why do we write clever code? I'll be honest about it. I'll tell you why. It feels good. When you write clever code, that proverbial hand comes and pats you in the back and says, "You're awesome." You write that code and nobody understands it. What do? You proudly take a printout and take to your mom and say, "Mom, look what I did at work." And mom looks at it and says, "Wow, that's a code you wrote." And you say, "Mom, not just a code I wrote. I wrote it and nobody understood it." And mom says, "I know you will grow up like this one day. I'm so proud of you," right? We write code that nobody understands and take pride in it. What a sad state of affair, isn't it? You know, Einstein said it takes a touch of genius to really move in the other direction. We should take pride in writing simple code, and yet we do this. I'll tell you about my own story. A client emailed me and said, "We need to make this change in the system." I looked at this and said, "Oh, it'll take me 10 minutes to make this change." Oh my gosh, 10 minutes. I'm not worthy of that change. I'm not going to solve this problem. I'm going to solve the mother of all problems. I'm going to solve the meta problem. I'm going to solve a pattern of all these problems. I spent an hour on this code. When I finished it, I had an out-of-body experience. Venkat got up and came and hugged me and said, "You are awesome, Venkat." Yes, absolutely. This is awesome code, isn't it? I felt so proud about it. And a few weeks later, an email came from the client saying something is terribly broken in production. I looked at it, immediately emailed them and said, "I've got this, I'll fix it." They said, "Oh, we know you'll fix it because you're good." I said, No. I'm going to fix it not because I'm good. I'm going to fix it because I'm the one who caused it. That brilliant solution had created completely backfired. What did I do? Removed the code I put in and put the 10-minute solution I had in mind. Never heard a problem again after that. I learned my lesson really the hard way. These days when I write code, my little brain says, "Oh, that's clever." I delete the code right away. And I start over because I want simple code, not clever code. Well, beautiful quote by Abelson and Sussman. They say that programs must be written for people to read and only incidentally for machines to execute. Code is written once, but it's read several times, and it is refactored several times, and it's improved several times. We need to really focus not on the cost of writing it, but the cost of maintaining it. That becomes extremely important. I have this theory. 10% of the code, we write ugly code for performance reasons. The other 90%, we write ugly code just to be consistent with the other 10% of the code. The other day, a programmer came and sat next to me with a big thud, and he said, I said, "Having a rough day at work, aren't we?" He said, "I was in this meeting. This programmer had written really ugly Python code. I can't believe how ugly the code is." And when I asked him, he said he had to write the code for performance reasons. "Tell me, Venkat, do you agree with this?" he said. I said, I can't answer that question, but let me ask you the question. Does the code have good performance, that ugly code? He said, "That's the problem. It doesn't." So here's the problem. Those who sacrifice quality to get performance may end up getting neither. And I see this often over and over and over. The code is now horrible. Nobody can understand. Nobody can maintain. We can't improve the performance either. That becomes incredibly hard over time. Well, a beautiful quote from Tony Hoare. He says, there are two ways of constructing a software design. One way is to make it so simple that there are obviously no deficiency. The other is to make it so complicated there are no obvious deficiencies. And we do this a lot of times. We don't even know what's broken in the code oftentimes. This one is a little odd one. I call this a Zinsser principle on writing. I came across this book, and this was written about 30 years ago. It's on writing nonfiction. It's on writing technical articles and blogs and books. Mr. Zinsser passed away a few years ago, but he left something phenomenal for us. I started learning English when I was 19 years old. I couldn't speak a sentence of English at that time. And then I started learning English and I started writing. And when I wrote my very first book, the people who edited my first book, they were not called as editors, they were called victims. And one of them came to me and said, "Is this your last book?" I said, No, this is my first book. And they said, "We're in trouble now." And they gave me this book actually and said, "Could you do us a favor? You'll save the world. Read this book before you write any other book." And I read it. I fell in love with this book because this book is packed with how to write good English. And as I was reading this book, my mind is wired to be a programmer. And as I was reading this book, I said to myself, oh my God, he's not talking about English, he's talking about programming. No, he's talking about English. But the point is, he's not a programmer, but everything he says there makes sense to a programmer. He writes 4 principles. The first principle he talks about is simplicity. So what is simplicity? Simplicity is, he says, when you write something, it's got to be really simple. That's what he says. Well, is that what we strive to do as programmers? Make things really simple. Mutability makes things complex. Long methods make things complex. Coupling makes things complex. So many things introduce complexity. You want to make things really simple. The second thing he talks about is clarity. You know, I noticed that when I read books, I a lot of times read books before it's published. I notice these authors do exactly the mistakes I often do, which is we jump from one concept to another. There's no flow, and lack of flow makes things really hard to understand. Clarity requires the flow. That's what we do in coding as well. He talks about brevity. Smaller sentences are better than longer sentences. Smaller chapters better than longer chapters. Smaller paragraphs better than longer paragraphs, he says. Isn't that what we talk about in code? Smaller functions are better than longer functions. Smaller classes better than longer classes. The last one he talked about, I first rejected it. I said to myself, humanity, we write code for computers. We don't care about humanity. How wrong I was. Humanity is the most important thing. But unfortunately, I'll tell you, we programmers leave a poor impression. People think that we are antisocial. We like to work with machines and we don't interact with people. I completely disagree. I'll tell you one thing, you may be surprised about this, because if you ever see me on a flight, I'll be the quietest person. And a lot of people don't know this. I'm actually an introvert. I'm not an extrovert. My stage persona is very different from my private persona. I'll be sitting in the airplane quietly coding, never to say a word next to the person next to me. I don't want to waste my time. I got books to write and code to write. It's more fun looking at what the code tells me than what the person next to me is saying. But then I will find out the person next to me, she is a programmer. This changes everything. We got to talk from checked exceptions to concurrency to deadlocks to what is the next best language. We will turn the plane into a riot because we got so much to talk about. And I finally realized programmers are not antisocial. We're just social among the right kind of people. That's all it is. But humanity is something we should really strive for, because every code we write, there is a human behind us who is trying to edit it, to make it better. So humanity is extremely important. Oh, let's not even go there. Commenting code. Notice I'm not saying don't comment, but comment why and not what. We have gone insane in this world. People are writing comments out of fear, and they're writing senseless comments. The other day, I was looking at a piece of code, and the code had a comment, kind of like this. It had a piece of code, I++, with this beautiful increment next to it. I always go to these programmers and I tell them, thank you. Because you see, these programmers have a lot of humanity. The reason is they know Venkat is getting old. They know Venkat is having trouble seeing. I've been increasing my glass power. I'm still having a hard time reading. So they said, Grandpa Venkat, in case you don't know, this is increment. I'm like, thank you, grandchild. I was not sure about it. Or people who write beautiful code like this, they'll say class, my class. And then within that, they'll say public my class with a beautiful constructor next to it. I'm like, if you don't know it's a constructor, you are in the wrong building, right? But the problem is, why do we write comments like this? I'll tell you why we write comments like this. There are a few reasons. And before I say it, I'll clarify this. I've been a professor of computer science for 35 years now. And I'll tell you, professors are the worst people on planet Earth. Because what do professors say? You write a code and say, Professor, here's a code I wrote for the assignment. And the professor looks and says, where are your comments? I wrote readable code. You will fail in this class if you don't comment. Here are your comments. And we've been taught to write bad code over and over and over. When you finish that and go to your work, you say, aha, but at work there are no professors, thank goodness. But there are corporate police. What do the corporate police say? Here's our coding standard. It requires 3 lines of comments for every 7 lines of code. Hey, what if I don't do it? No bonus for you. Here are comments. We live under threat. After 15 years, what the heck? Just write the comment and be done with it. And we write so much comment which is meaningless. And we got to the point where we should really care about quality of code we write and avoid senseless comments. Don't comment to cover up bad code. And when people tell me, I don't understand this code, write some comment, I say time out. I don't understand this code, refactor it. I want the code to be understandable when I read it. We should write expressive, self-documenting code. Unit tests can be a good documentation. Good variable names are documentation. Good function names are documentation. So many ways we can document the code. And then write a few lines that say why this code exists. That why is the most important question, not what the code is doing. Why did we even write it in the first place? What's the significance? What are the special conditions we should be aware of before we get into it? I'm going to say a good code is like a good joke. Now, this is the first rule of telling joke. I've taught my children this one thing really well. If you ever tell a bad joke, you should never explain it. Because when you explain it, what do people do? They listen to you and say, yeah? And what's funny about that? Let me re-explain it. It's a very long dinner when you go with people who explain their jokes. Well, you say a joke and they don't get it. The only right response is, you know what? Never mind. Just don't worry about it. Ignore it. So you tell a joke, nobody gets it. Never mind. Then you go home, sit down quietly, and think about why your joke fell so flat. Refactor your joke. And then try it with a new group of people the next day and see how it goes. So a good joke, a good code is like a good joke. Trying to comment a piece of code is like trying to explain a bad joke. So lay it out and walk away. If it's not clear, refactor it. That's a better way to communicate through code. So you want to really be expressive in the code. That is absolutely important. Having said this, I was in Washington, D.C. to speak at a conference. In the morning, I said to myself, hey, before the conference, I'll take a shower. Good idea. And these days, we live in days when you're angry, you don't take a shower. You tweet about it. I got into the shower. I got so angry. I saw this, and I was intellectually insulted. Because why don't you give me a shower I can use instead of documenting how to use it? I got so angry, I jumped out of the shower, grabbed my smartphone, took a photo, and I tweeted it. And here's my tweet. My tweet said, those who can't design are condemned to document. This happens a lot, isn't it? You look at a function, int p1, int p2, int p3. What are p1, p2, and p3? Read the documentation, like why? This has gone crazy. The other day I was walking to a door. On the door it said, push and pull on the same door. I'm like, what do I do now? This is crazy world we live in. Other day I had cold. My wife said, take these pills. I should have just quietly followed an instruction. I should have tossed it. Instead I started reading what was written on it. And it said, take 2 tablets by mouth. I'm like, what are the options here? I'm curious. This has gone crazy, isn't it? We document everything. Why can't we make it intuitive? Look at the door over here. So beautifully designed, isn't it? And you can find out, do I push or pull? The lever shows you there is a very subliminal message over there that says, here's how you operate it. How about design being really intuitive? That'll be really nice, isn't it? Order 3, what in the world? Oh, large coffee. Why not use an enum? Because it becomes really expressive, isn't it? So document code using well-chosen meaningful names. Use comments to describe its purpose and avoid and constraints. Avoid writing comments as a substitute of good code. Avoid writing long methods. Let me ask you this question. Who here believes long methods are a good idea? Not a single person raised the hand. One person. There's always that one person. There's a reason why he's so much near the door you can see, right? Just kidding. Well, let me ask you this question. Who here has seen long methods at work? Did you notice that? The entire room raising the hand. This is called, he doesn't want to let go of his hand, right? Keeps raising. This is called cognitive dissonance. I've got a good news and a bad news. Here's the good news. Those long methods, you didn't do it. You just told me you don't believe in it. You didn't. Here's the bad news. The people who believe long methods are a good idea, they're at work today, making those methods longer as we speak. Now, why are long methods such a bad idea? Long methods are hard to understand, hard to debug, hard to work with. They are really hard to maintain. They are not testable. They lead to duplication of code. They end up becoming longer. This is grim, isn't it? And I can keep going. So many reasons why long methods are a bad idea. I shouldn't have done this, but I did. I was speaking in Voxxed, Belgium a few years ago. Voxxed, Belgium, if you've not been to, it's in a theater. In front of you, there are 800 seats. And the room is dark. Everyone in the room is this big compared to the entire room. I shouldn't have asked this question. Right in the middle of my talk, I asked the question, what's the longest method you have seen? Right from the middle of the room came a voice, 40,000. I said, your entire class? No, one method. I said, where do you work? In hell? And I finished my talk. This gentleman comes up to me and says, I am the one who said 40,000. He was not joking. I saw in his eyes that pain. And I looked at him and said, 40,000? He said, it's actually worse than that. I said, how could it be worse? He said, I didn't know it, but I got hired full-time to refactor this one method. I'm like, I didn't even know this a job exists. Can you imagine? Hey, what's your job? I'm a director of Saki code. I maintain one function. My entire life's mission is to refactor the one method. I'm not even kidding with you. The next year, thankfully, I was invited to Voxxed, Belgium. I was getting ready to give my talk, and the gentleman walks over, and he looks at me and says, Venkat, do you remember me? I said, how could I ever forget you? He said, I don't know why this is happening. These are true words. He said, I don't know why this is happening, but since I got up this morning, I have a brotherly love towards you, Venkat. Can I tell you my progress over the year? I said, I will be your brother today. I'll be your brother forever. Tell me how it's going. Well, I worked the entire year to the date on this one method with 40,000 lines. I'm proud to tell you I'm down to 30,000 lines. We both agreed one day we'll meet when he'll tell me he's got 0 lines in that function. It's kind of scary, isn't it? How do you maintain code like this? So how long is long? It turns out length is not the factor. Programmers cannot agree on the length of a method. We cannot agree on what, hey, 100 is big, 200 is big, 50 is big. No. One guy said, I'll tell you, a method is not long if you can see the entire method in the window, he said. The minute he said it, somebody said, what's your font size? There is no way to win this battle. It turns out the length of the method is not the length, but it's actually the width, the number of levels of abstraction. A method should have one level of abstraction, not many. So it's not about how many lines of code, but the number of levels of nesting, the number of decisions you make in a function. That's what we really need to keep down, because that's where the complexity really comes into methods. The next thing I'll say here is give good, meaningful names to methods. I mean, seriously, would you do this? Would you name your child P? Child, what's your name? P? Is that your full name? Yeah, absolutely, there's no initials. My full name is P. There's only one thing I can tell you when a child's name is P. Both the parents are programmers. If only one parent is programmer, the other one would say, are you crazy? When both the parents are programmers, sweetie, what do you want to call our next child? I'm thinking P. Oh, I love it. This is what happens when both parents are programmers, right? And we don't give such names to children. We give respectable names. I have this theory, and I can tell you about this in my personal experience. A programmer, one who can name their children quickly, but has a really hard time naming their variables. I actually named my child on an email. My wife still complains about it. And I just named my child in the email. And she said, are you serious? This is the name you want? I said, I love this name, but I'm really sorry. Can we talk about this later? I'm struggling to name this variable, right? It's really hard to give names for variables. I was working for a client. I'm not even kidding with you. One license is $1 million. And the people who write this code are PhDs in their field. And they called me to help them on a project. I was working with them. We were looking through production code. Somebody brought up a code, went to another file, said, oh, excuse me, can you go back to that again? And he did. I said, can I take a photo of this? He said, yeah, but if you never tell who we are, promise I will never tell who you are. And so thankfully he let me take a photo. And I did. And the photo I took, oh, sorry, not this. The photo I took was the line below this line. In production code, I saw this. Right below this line, it said, God help me. I have no clue what this means. Can you believe working on a project like this? And I asked him, it's in production. He said, uh-huh. I said, why didn't you remove it? He said, out of respect for the person who wrote it. I think this was his last message. He died after this, I think, couldn't take it anymore. The point really is, you have to maintain code like this, how horrible that is. So variable names represent abstraction. You want to make sure you're able to understand what the code is doing. That becomes extremely important way to communicate. If we don't really have good names, it's a sign we don't understand what abstraction really means. So if you cannot name a variable or a function appropriately, it may be a sign we haven't really understood the purpose of this code we are writing. So we need to really take the time to do it. I'm going to say do tactical code reviews. I'm a huge fan of code reviews. Let me emphasize what I mean by this about code reviews. Well, one of the things I want to emphasize here is when you tell code reviews, people don't like it. One of the reasons is the boss comes to you running and says, did you send an email that you're going to have code review next Thursday? Uh-huh. Heck no. Because the last time you organized a code review, there was a fight. We had to call the cops and 2 people quit. No more code review for you. Well, the reason it gets political is we do it the wrong way. We do what's called tactical code review. We do it incrementally. We do it every day. And when I write a piece of code, he's going to review the code this time. The next piece of code I write, he's going to review it. The third piece of code I write, he's going to review it. We rotate among the people who are going to review the code. And also, when I start reviewing the code, I don't review the code. I review the test first. And when I review the test, I find tests that are missing, tests that are poor quality. Hey, if we can write poor quality code, we can write poor quality test as well. So we start with reviewing test. Then we also review the code. When I review the code, I've changed a few things. This happened about 9 years ago. When I was reviewing the code, I found a bug. And at that point, when I find a bug, I usually write a paragraph describing what the bug is. And that day I said, hey, wait a minute. Rather than writing a paragraph, why not write a failing test for it? And I wrote a failing test, and it failed, and I checked it in. An hour later, the programmer came to me and said, I know what you did there. You wrote a test, didn't you, because you found a bug? I said, yeah, I hope that was useful. He said, did you know there were 3 bugs, not 1? And then he said, I figured you wrote a test. I guess that's the right thing to do. So I wrote 3 more tests for the bugs I found, and I fixed it. I'm like, my job here is done, right? That's what you really want to do. Promote writing tests when you find a bug before you fix it. But also, recently I was doing that, and I couldn't write a test that fails. I struggled with it. Then I realized it was not a bug. I had not understood the code properly. And then my recommendation was to refactor it because it said something other than what it really was. And so that became a lot more easier. And the last thing I want to tell you here before we get this done is to reduce state and state mutation. If you ask me, Venkat, tell me one thing you do today different from what you have been doing for 10 years. And that is, I write code with fewer state. When I pair with programmers today, the first thing they do, public class. Second thing, private field. I'm like, whoa, why do you write a field? Because we need it? It's like, no. Let's write a method. Let's bring the state only when we need it. I don't want the state to be proclaiming. I want the behavior first and the state to support it. I'm going to say, think more, type less, aim for minimalism. Fewer state, less mutability, and just enough code for the relevant known parts of the system. I'm going to be a little philosophical and say, messing with the state is the root of many problems, both in software and in politics. And it turns out mutability needs company. It a lot of times hangs around with bugs. And we see more mutability we do in code, the more bugs we have in code as well. We should strive to really minimize mutability as much as we can. So we talked about 12 ways to make the code suck less. We talked about schedule time to pay technical debt, favor high cohesion, favor loose coupling, eliminate coupling where possible. We talked about the programming with intention, we talked about avoiding primitive obsession. We talked about as much as possible to favor declarative style and functional style to minimize accidental complexity where it makes sense. Write clear code rather than clever code. Apply the Zinzer principle on writing to programming as well. Comment, but comment why, not what you are doing. Avoid long methods using a single level of abstraction principle. Give good names for variables and fields and methods and everything we create. Do continuous tactical code reviews and reduce state and state mutation. If I can give you one last advice on how to get better, this is what I've realized over time. And that is, the first step in becoming a better programmer is to let go of the conviction that we can code it once and get it right on the first write. We never really write code and be done with it. We keep improving code. We want really, the real challenge here is not to write the code. The real challenge is to write maintainable code. I think every step we can take to write maintainable code is really what we are doing for humanity, and that is our professional responsibility. I hope that was useful. Thank you.